Hello dear students, all of you welcome to Vidyan classes. Today we will start determinant. In this lecture we will discuss definition of determinant, sign of Aij, minors, cofactors of Aij, and expansion of determinant of a matrix of order 1, 2 and 3. Aij represent the element of ith row and jth column of the determinant or matrix. First definition of determinant. Let capital A be a matrix of order n, where Aij is the element of ith row and jth column. If Aij represent a number or numbers that is real or complex, or a function or functions, then let capital Aij be a matrix of order n, where Aij is the element of ith row and jth column. If Aij represent a number or numbers that is real or complex, or a function or functions, then the matrix capital A is called a is called a determinant, and denoted by dA, or determinant of A, or del. It is the definition of determinant. Capital A is a matrix of order n, where Aij is the element of ith row and jth column. If Aij represent a number or numbers that is real or complex, or a function or functions, then the matrix capital A is called a determinant, which is denoted by dA, or determinant of A. This symbol is read as determinant of A, not modulus of A, or del. Clear? First, A is a square matrix. If Aij represent a real or complex number or a function, then the square matrix capital A is called a determinant. From the definition, it is clear that A is a square matrix. A, I, J are the real or complex numbers or functions. Then matrix A is called the determinant, which is denoted by dj or determinant of A or del. This symbol is read as determinant of A, or we can define a square matrix associated to a number or numbers. A square matrix associated to a number or numbers that is real or complex or function or functions. A square matrix associated to a number or numbers that is real or complex or function or functions. Then the square matrix is called a determinant. A square matrix associated to a number or numbers that is real or complex or function, then the square matrix is called a determinant, which is denoted by dj or determinant of A or del. For example, capital A is a matrix of order 1. Order 1, that is 1 cross 1, implies it is a square matrix of order 1. dta or determinant of A or del is equal to determinant A11. It is a square matrix of order 1. This expression is read as determinant having element A11. It has 1 row and 1 column. Example 2, capital A is a matrix having elements A11, A12, A21, A22. 2 cross 2 is a square matrix of order 2. dta or determinant of A is equal to del is equal to determinant having elements A11, A12, A21, A22. These are the elements of the determinant which are real or complex numbers or functions. Clear? Example 3. Let capital A is a matrix having elements A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a matrix of order 3. It has 3 rows and 3 columns, which implies determinant of A or dta or del is equal to determinant having elements A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a determinant of order 3. These are the elements of determinant A. Or we can say the square arrangement of real or complex numbers or functions between two vertical lines. The square arrangement of real or complex numbers or functions between two vertical lines is also called a determinant. Clear? It is the third definition of determinant. The square arrangement of real or complex numbers or functions between two vertical lines is also called a determinant. Note, all matrices, all square matrices, all square matrices are determinants. All square matrices are determinants. Since by the definition a square matrix associated to a number or numbers that is real or complex or functions, then the square matrix is called a determinant. So all square matrices are determinants. For a square matrix, capital A, this symbol is read as determinant of A and not modulus of A. For a square matrix capital A, this symbol is read as determinant of A and not modulus of A. Clear? For example, A having element 2. Determinant of A is equal to is a square matrix. A is a square matrix of order 1. This symbol is read as determinant of A, not modulus of A. It is also read as determinant of 2, not modulus of 2. Clear? This symbol is read as determinant of 2, not modulus of 2. Clear? Is read as determinant of 2. This symbol is read as determinant of 2. It is also read as determinant of A. A is a square matrix of order 1. Clear? Okay. Note down. Next, sign of Aij. Aij represent the element of ith row and jth column of the determinant. What is the sign of Aij? Let Aij be any element in the determinant del. Del represents the determinant. Aij is any element in the determinant del. The sign of any element Aij is defined by -1 to the power I plus j. The sign of Aij is defined by -1 to the power I plus j. Example, let del be the determinant of order 2. That means 2 cross 2. Order 2 or 2 cross 2. Del is the determinant having elements A11. It is the element of first row and first column. It is the element of first row second column. It is the element of second row first column. It is the element of second row and the second column. The sign of A12 is an element of del. What is the sign of? The sign of A12 is -1 to the power 1 plus 2, which is equal to -1. That is negative side. Similarly, the sign of a to 2 is minus 1 to the power 2 plus 2, which is equal to 1. That is positive side, and so on. And so on. The element of A11 is positive side, element of A12 is negative, A21 is negative, and A22 is positive. So the sign of the elements of the determinant del, the sign of the elements of the determinant del is given by, it is a positive sign, it is a negative, it is a negative, it is a positive. Clear? These are the sign of the elements of the determinant of order 2. Next example, let del is the determinant of order 3. It is the determinant of order 3. A11, A12, A13, A21, A22, A23, A31, A32, and A33. It is a determinant of order 3. That means 3 cross 3. The sign of A13 is minus 1 to the power I plus j, that is 1 plus 3, which is equal to 1, that is positive side. The sign of A22 element of second row and second column, minus 1 to the power I plus j 2 plus 2, that is equal to 4, which is equal to 1, that is positive side. Clear? Sign of A32 is minus 1 to the power 3 plus 2, that is equal to minus 1, that is negative side. Clear? So the sign of elements of the determinant determinant del of order 3 cross 3 or 3 is given by positive, negative, positive, negative, positive, negative, positive, negative, and positive. These are the sign of the elements of the determinant del of order 3. Similarly, the sign of the elements of order elements of the determinant similarly the sign of the elements of the determinant of order 4 or 4 cross 4 is given by plus minus plus minus minus plus minus plus plus minus plus minus minus plus minus plus. Clear? It is the element of first row and the first column. It is the element of fourth row, second column, I is 4, j is equal to 2, minus 1 to the power 4 plus 2, that is equal to 1 to the power 6 is equal to 1. It is a positive sign. From the above discussion, the diagonal elements are positive sign. Here the diagonal elements are positive sign. Here the diagonal elements are positive signs. Clear? Note. It is A11, it is A22, it is A33, it is A44. The sign of diagonal elements are positive. Clear? It is the sign of the element Aij. Aij represent the element of ith row and jth column. Clear? Okay. Write down. Minor of Aij. Definition. Minor of an element Aij of a determinant minor of an element Aij of a determinant is the determinant obtained by deleting the ith row and jth column minor of an element Aij of a determinant is the determinant obtained by deleting the ith row and jth column in which Aij lies. Minor of an element Aij of a determinant is the determinant obtained by deleting the ith row and jth column in which Aij lies. Aij represents the element of ith row and jth column of the determinant. From the definition, it is clear that minor of an element is a determinant which is obtained by deleting the ith row and the jth column in which Aij lies. The minor of Aij is denoted by Mij. Clear? From the definition, it is clear that minor of an element is a determinant which is obtained by deleting the ith row and jth column in which Aij lies. The minor of Aij is denoted by Mij. Next, cofactor of Aij. Cofactor definition: cofactor of an element, cofactor of an element Aij is written as capital Aij and defined by Aij is equal to -1 to the power I plus j Mij. Mij represents the minor of an element Aij. Capital Mij represents the minor of an element Aij. Cofactor, which is denoted by Aij, defined by Aij is equal to minus 1 to the power I plus j minor of aij. This represent the sign of aij. Minus 1 to the power I plus j represent the sign of aij. Not minor with appropriate sign is called cofactor. From aij is equal to minus 1 to the power I plus j into mij. Minus 1 to the power I plus j represent the sign of aij. Mij represent the minor of aij. Minor with proper sign is called cofactor. Minor with appropriate sign is called cofactor. Clear? Example, find minor and cofactor of A23, that means element of second row and third column in the determinant del is equal to determinant having elements 1, 2, 3, 0, 2, 4, minus 1, 2, 1. Find minor and cofactor of A23, that means element of second row and third column in the determinant del having elements 1, 2, 3, 0 to 4, minus 1 to 1. Solution. Minor of the element A23, that means element of second row and third column. It is the element of second row and third column. A23 represents the element of a second row and third. It is the second row and third column. Minor of A23, that is equal to minor of 4, which is denoted by capital A 2, 3 is equal to minor of aij is a determinant deleting the ith row and jth column. Here I is equal to 2 and j is equal to 3. Minor of A23 which is equal to minor of 4. A23 means that is equal to 4, which is denoted by M23 is the determinant deleting the second row and third column. Second row and third column. It gives the determinant having elements 1, 2, minus 1, 2. Clear? Clear? Minor of A23 is equal to minor of 4, which denoted by M of 2, 3. Having elements deleting second row and third column, it gives a determinant having 1, 2, minus 1, 2. Clear? Okay. Next, cofactor. Cofactor of A to 3, that is cofactor of 4, denoted by capital A 2 3 is equal to -1 to the power 2 plus 3 m 2 3, which is given by -1 to the power 5, that is minus determinant having minor of 2 3. Minor of 2 3 is given by 2 -1 and 2. Clear? Cofactor of A 2 3, that means cofactor of 4, which is denoted by capital A 2 3, which is same as -1 to the power 2 plus 3 minor m 2 3. That means minor of the element of second row and third column. Minor with the proper sign. The sign of this is minus. Minus with the proper sign is called the cofactor. It is the minor and its sign. Minor with the appropriate sign is called cofactor. So minor of A 2 3, that is equal to 4, which is given by this, and cofactor is the cofactor of A 2 3 is equal to cofactor of 4, which is denoted by A 2 3 -1 to the power 2 plus 3 m 2 3. It is the minor of the element in second row and the third column. It is the minor and its sign. Minor with the proper sign or appropriate sign is called cofactor. So minor of 4 is the determinant having elements 1 2 -1 2, and the cofactor is the negative of the minor of 4. It is the cofactor, it is the minor. Are we clear? Okay, write down. Expansion of determinant of a matrix of order 1, order 2 and order 3. There exist 3 cases: order 1, order 2 and order 3. Case 1, for order 1. Let capital A be the matrix having element A11. Is a square matrix. Of order 1. It has one row and one column. So it is a square matrix of order 1. The determinant of the matrix capital A is written as DT or determinant of A. This symbol is read as determinant of A, not modulus of A, or del. Written as in this form, and defined as determinant of A or dA which is same as del is equal to determinant of A11 is equal to A11. Determinant of A11 is A11. That means determinant of a single element is itself. For example, determinant of 2 is equal to 2, determinant of minus 2 is equal to minus 2, determinant of 5 is equal to 5, determinant of minus 5 is equal to minus 5. Since determinant of A11 is A11, determinant of 5 is 5, determinant of minus 5 is minus 5, determinant 2 is 2, and determinant minus 2 is minus 2. Clear? Since determinant of A11 is equal to A11, that is not determinant of a single element is itself. Determinant of a single element is itself. Clear? Case 2. For order 2. Let capital A be the matrix having elements A11, A12, A21, A22. Is a square matrix of order 2. Is a square matrix of order 2 or 2 cross 2. The determinant of the matrix capital A is written as determinant of A or determinant of A or dA or del. Determinant of A having element A11, A12, A21, A22. It is the matrix form of A, it is the determinant form of A. It is a matrix of order 2, it is a determinant of order 2. The determinant of the matrix capital A is written as this form or dA or del, which is same as dA or del. dA. We have to find out the expansion of the determinant. Expansion of the determinant capital A expansion of the determinant capital A along first row. First row means R1. Expansion of the determinant capital A, it is the determinant capital A along first row. Clear? We have to find out the expansion of the determinant for order 2. The expansion of determinant A is defined by determinant of A is equal to -1. Expansion of the determinant capital along first row. It is the first row. -1 to the power 1 plus 1. A11. M11 plus -1 to the power 1 plus 2. A12. M12. -1 to the power 1 plus 1. We will expand the determinant of order 2 along first row. First row contains A11, A12. -1 to the power 1 plus 1 represent the sign of the element A11. M11 represent the minor of the element A11. Clear? Similarly, -1 to the power 1 plus 2, A12, -1 to the power 1 plus 2 represent the element of A12 and M12 represent the minor of the element A12. -1 to the power 1 plus 2 represent the sign of the element A12 and M12 represent the minor of the element A12. Clear? It is same as -1 to the power 1 plus 1 represent the sign of the element A11. Sign of A11. A11. M11 represent minor of the element A11. It represents the sign of A11. M11 represent minor of the element A1 plus sign of A12 into A12 minor of the element A12. Clear? It is the definition of expansion of the determinant of order 2 along first row, which is same as sign of A11 -1 to the power 1 plus 1, that is equal to 1. A11 minor of the element A11. Minor of the element A11 is the determinant. Deleting the rows and the columns in which A11 occurs. So minor of A11 is 2, 2, which is a determinant. Determinant of A 2, 2. Minor of an element is a determinant. Minor of this is a determinant of A 2, 2. Plus sign of A 1, 2, that is minus 1 to the power 1 plus 2, which gives minus 1. A 1, 2. Minor of the element A 1, 2, which is a determinant. Deleting the first row and the second column, it gives determinant of A 2, 1, which is same as A 1, 1. Determinant of a single element is itself, so it is A 2, 2. And it gives minus A 1, 2. Determinant of a single element is itself A 2, 1. A 1, 2. Determinant of A 2, 1 is A 2, 1. It is the expansion. It is the expansion of the determinant of order 2 along first row, which is same as A 1, 1, A 1, 2, A 2, 1, A 2, 2. The expansion of the determinant of order 2, simple we can find out this into this minus this into this. A1 1 into A 2, 2, it gives this. A 1, 2 into A 2, 1. It is the this into this minus this into this. It gives this result. Clear? Simple we can find out the determinant of the order of determinant of order 2 by a simple form, that is this into this minus this into this, which gives this result. Clear? Suppose we will expand the given determinant along column 2. Expansion of determinant A along C2. In this case, we find the determinant along row 1. Now we will find the determinant of A along column 2. It is defined by determinant of A along column 2. Taking this column, it is column 2. It gives minus 1 to the power 1 plus 2. A 1, 2. Minor of A 1, 2. Plus minus 1 to the power 2 plus 2. A 2, 2. M 2, 2. Clear? Expanding the determinant along column 2. Minus 1 to the power 1 plus 3, it is minus 1. A 1, 2. What is the minor of A 1, 2? A 1, 2. Deleting this row and this column, it gives the determinant A 1, 2. Minor of an element is a determinant. Deleting the corresponding row and the column. Plus minus 1 to the power 4, that is equal to 1. A22. Minor of the element M22 is the minor of the element A22, which is a determinant deleting the corresponding row and the column of A22. This column and this column is deleted. It gives A11 determinant, which is same as determinant of A11 is A11 into A22 minus A12. Determinant of A12 is minor of the element A12 is A21. It is A21. Minor of the element A12 deleting this row and this column, it gives determinant of A21. Determinant of A21 is itself, that is A21, which is same as A11, A12, A21, A22. The above result can be obtained multiplying this into this minus this into this, gives the above result. For order 2, we can find out the value of the determinant, this into this minus this into this, gives the above result. Clear? Similarly, expanding R2 and row 2 and column 1, we will find the same result as A11, A22 minus A12 into A21, which is the same as A11, A12, A21, A22. This into this minus this into this. Simply we can find out the value of the determinant or expansion of the determinant, this into this minus this into this, for order 2. Clear? Expanding first row, we will get this result. Expanding second row, we will get this result. Expanding column 1, we will get this result, and expanding column 2, we will find the same result, this. From the above discussion, it is clear that the value of the determinant remains the same, expanding any one row or any one column. Note, the value of the determinant remains same, expanding any one of the rows or columns. Expanding along first row gives this result. Expanding along second row gives this result. Expanding in column 1 gives this result. Expanding in column 2 it gives this result. Therefore, the value of the determinant remains the same expanding any one of the rows or columns. For order 2, simple we can find out the value multiplying this into this minus this into this. Clear? For example, find the value of the value of the determinant of the following. Find the value of the determinant of the following. For order 2, 1, 2, 3, 4 is a determinant. Its value 1 into 4. This into this minus this into this. 1 into 4 minus 2 into 3 is equal to 4 minus 6 is equal to minus 2. Simple we can find out this. One, 2, 6, 12. 1 into 12, this into this minus this into this. Minus 2 into 6 which is equal to 12 minus 12 is equal to 0. Clear? Determinant of 2, 3, 4, 7. This into this minus this into this. 2 into 7 minus 3 into 4 which is equal to 2 into 7 minus 3 into 4, 14 minus 12 is equal to 2. 4 minus 6, this into this minus this into this, that is 4 minus 6 is equal to minus 2. This into this minus this into then 12. 12 minus 12 that is equal to 0. 2 into 7 that is 14. 3 into 4 that is equal to 12. 14 minus 12 is equal to 2. These are the value of the determinant for order 2. Clear? Clear? Okay. Write down. Case 3 for order 3. Let capital A is a matrix having elements A11, A12, A13, A21, A22, A23, A31, A32 and A33. Be a square matrix. Be a square matrix of order 3. The determinant of the matrix capital A is written as determinant of A having elements A11, A12, A13, A21, A22, A23, A31, A32, A33. A is a square matrix of order 3. Order 3, or we can write 3 cross 3. The determinant of the matrix capital A is written as this or detail, or detail, or which is same as detail. It is the determinant of order 3. Expansion of determinant A along, we can expand the given determinant along first row or second row or third row or first column, second column or third column. Expansion of a determinant A along, suppose we will expand the given determinant along column 2, that is C2. In determinant of order 2, we have discussed determinant of order 2. We have discussed the value of the determinant remains the same, expanding any one of the rows or any one of the columns. Similarly, for order 3, the value of the determinant remains the same along any one of the rows or any one of the columns. Suppose we will expand the given determinant along column 2. It is defined by determinant of A along column 2. We will expand this along column 2. Minus 1 to the power 1 plus 2 A12 M of 12 plus minus 1 to the power 2 plus 2 A22 M22 plus minus 1 to the power 3 plus 2 A32 M32. Minus 1 to the power 1 plus 2 represent the sign of the element A12 and M12 represent the minor of the element A12, which is same as minus 1 to the power 1 plus 2, that is equal to minus 1 A12. Minor of the element A12 is a determinant, deleting the first row and the first column. A12 deleting the first row and the second column, deleting the first row and the second column, it gives A21, A23, A21, A23, A31, A33. Deleting the corresponding element, that is A12, that means deleting row 1 and column 2, it gives the determinant having elements A21, A23, A31, A33 plus minus 1 to the power 4, that is equal to 1, A22, minor of the element A22. Deleting the second row and the second column, it gives A11, A13, second row and the second column, A31, A33 plus minus 1 to the power 5, that is minus 1, A32, M32. Deleting the third row and the second column. Third row and the second column, it gives the determinant A11, A13. Deleting the third row and the second column, A21, A23, which gives minus A12. It is a determinant of order 2, which is defined by this into this minus this into this, A21, A33 minus A23, A31. A22, it is a determinant of order 2, this into this minus this into this, A11, A33, A13, A31 minus A32. It is also a determinant of order 2. It gives A11, A11, A23 minus A13, A21. Clear? Okay. Which is same as? Which is same as minus A12, A21, A33 plus A12, A plus A12, A23, A31 plus A22, A11, A33 minus A22, A22, A13, A13, A31 minus A32, A11, A plus A32, A13, A1. Expanding the second column, it gives this result. We denoted by star. Similarly, expanding row 1, expanding along row 1, row 2, row 3, column 1 and column 3, we will get the same result of star. Expanding along column 2, it gives this result. If you will expand the same determinant along row 1, row 2, row 3, column 1 and column 2, we will get the same result as a star. That means value of the determinant remains the same expanding along any one of the rows or columns. Note the value of the determinant remains same expanding along any one of the rows or columns. The value of the determinant remains the same expanding along any one of the rows or column or any one of the columns. For easier calculations, we shall expand the determinant. We shall expand the determinant along the row or column that contains maximum number of for easier calculations, we shall expand the determinant along the row or a column that contains maximum number of zeros, so that the calculation will be easy. For example, A is a matrix having element 1, 2, 0, 0, 3, 5, 3, 4, 0. A is a determinant having elements 1, 2, 0, 0, 3, 5, 3, 4, 0. Row 1 contains only 1, 0. Sorry, column 1 contains only 1 0, column 2 has no 0, column 3 contains 2 zeros. So the calculation will be easy expanding along column 3. Expansion along C3. Determinant of A is equal to sine of 0 plus minus plus, that is the plus sign. Element A13, that is 0. Minor of 0, 0 3 3 4. Plus minus plus minus the sign of 5 is 5. The sign of 5 is minus 1. So minus 5 into determinant of the minor determinant of 1 2 3 4. Deleting the corresponding row of 5, row and column of 5. It gives 1 2 3 4. Sign of 0 is 0. Deleting the corresponding row and column, it gives 1 2 3 4. Clear? Expanding along column 3. Its sign is positive, plus minus plus. A13, that is 0, and the minor of A13 is this. That means deleting row 1 and column 3. It gives 0 3 3 4. Sign of 5 is minus, so it is minus 5, and the minor of 5 is 1 2 3 4. Its sign is positive, element is 0, minor of 0 is 1, determinant of 1 2 0 3. Minor of 1 2 0 0 3. Minor of 0 is the determinant having elements 1 2 0 3. Clear? Okay. This result is 0. This result is minus of 5 into 1 into 4 minus 2 into 3, 4 minus 6 plus 0, which is same as minus 2 into 2 is equal to 10. Clear? For easier calculation, we will expand the third column since it contains maximum number of 0. Expanding any one of the row or a column, it gives the same result. Expansion along, suppose we will expand the given determinant along row 2. Expansion along row 2. It will give the same result, that is 10. A determinant is equal to plus minus, it gives 0, and minor of 0, that is deleting the corresponding row and column of 0, it gives 2 0 and 4 0. Sign of plus minus plus. Minor of 3, it gives, deleting the corresponding row and the column, it gives 1 0 3 0. expansion through row 2 plus minus minus its sign is minus 5, minor of 5, deleting the corresponding row and the column of 5, it gives 1, 2, 3, 4. The first value is 0, the second value 3 into 0 minus 0 minus 5 into 4 minus 6 which is equal to 0 plus 0 minus 5 into minus 2, that is plus 5 into 2 which is equal to 10. Along column 3 the result is 10. Along row 2 the result is also 10. The value of the determinant remains the same, expanding any one of the rows or any one of the columns. Clear? Okay. Write down